and share my screen. And again, just problem set 2 and homework 18 done by the end of the day today. Test 2 is available after class today. And right now it's set so that it needs to be completed by the end of the day tomorrow. Is everybody going to have time between the end of the class today and the end of the day tomorrow in which to do that? If that's going to be problematic for you, either stick around and talk to me at the end of class. I can make individual settings for you or send me an email. All right? The practice test is that problem set that's in my labs. And let's go through and look at one of those. I'm going to ask a lot of help though in doing it so that hopefully you folks can do the lion's share of the work for me. And I'm a jerk. Before we do that, does anybody want to look at anything from any homework? Does anybody have any questions on any back homework questions that they'd like to visit before we started doing that review? No? All right, then before we do, just thinking about it for the test, there are a few formulas that you need to know. You need to know how to plot points. You need to be able to grab a line from a table. And making a table, you need to know the formula for the slope, which again is usually a lowercase m, and it's the rise over the run, or the difference in the y's over the difference in the x's. You need to be able to use the point slope formula to find the equation of a line. And so you need to know that. That's y minus the y value is equal to the slope times x minus the x value. You need to be familiar with your slope-intercept form. Which is your y equals mx plus b, where m is the slope and b is the y-intercept. You need to be able to find your intercepts either by looking at a graph or by substitution for the x-intercept. We substitute y equals 0 and solve for x. For the y-intercept, we substitute x equals 0 and solve for y. And other things that you need to know is if lines are parallel, they have equal slopes. If lines are perpendicular, the slopes are negative reciprocals. You need to know that if you have a horizontal line, the slope is 0, and its formula is y equals a number. And if we have a vertical line, the slope is undefined. And the equation is x equals a number. I think that's pretty much, if you want a one-page synopsis of the chapter. To the best of my memory, that would be it. Now, let's go, and nobody has any homework questions. Let's go look at a problem set then to review for the test. we'll go through a practice test together. So this one's a little bit shorter than the last one. It has like 16 or 17 questions. This first asks you to find ordered pairs for the fill in the table and then graph the line. Also, I want to tell you folks that I'm playing ping pong with the screens today. I'm sorry. With the test, you must submit the work in Blackboard or the grade will not count. You must submit pictures of your supporting pencil and paper work in Blackboard.
Even with the practice test?
Not with the practice test, just with the test itself. Okay?
Okay.
So over here, and what I write on the screen would probably be pretty close to what the supporting work would be. We're given X values, and we want to find Y values. The equation is Y equals 1/2 X. I like to make the table with the equation in the middle. So if X is 0, Y would be 1/2 0, which is 0. If X is -4, Y would be 1/2 times -4, which is -2. And if X is 4, Y would be 1/2 times 4, which is 2. Is everybody comfortable with that? And I'm thinking as I go through and fill this in, they're going to not let me move on to the graph until I type those in. So the first one is 0. The second one is 2. And the third value is 2. And now when I go to graph it, is everybody comfortable? We're going to take the straight line tool. We'll go on one point. Oh, no, let's not use that point. Straight line tool. We'll go to the point 0, 0. And then our next point, let's go to -4, -2. And then when I look at it, my line does indeed go through that third point 4, 2. How's everybody with graphing a line from making a table of values? So far we're good?
Yeah.
So let's click that, look at the next question. Next question asks you to graph the linear equation y equals -2. With this one, you're not given a place to make a table. If you want to, you can, but in my mind, that's being a glutton for punishment. We've got this solved for y already. There's no x, so the slope is 0. That line y equals -2. If we've just got y, does everybody remember that that's going to be that horizontal line? It's going to cross my y-axis at -2. So again, I'm going to take my line tool. I'm going to go to -2 on the y-axis and then click any other point on the line. But does everybody remember that y equals is going to be that horizontal line? And so we've got it. How's that one for everybody?
Okay.
Okay. Then, next question. We're asked to identify the intercepts. With this question, a lot of times, looking at the answers that people put on this test, usually I make a typed copy of this into a pencil and paper class test. The biggest mistake that people do is they don't type their points as an ordered pair and use commas to separate. So for the x-intercept, the x-intercepts are the points where I cross the x-axis. And so my first one of my x-intercepts would be that point -5, 0. And then my other x-intercept would be that point 5, 0. And remember, if I'm on the x-axis, the y value is 0. And then for my y-intercepts are going to be points on the y-axis. They'll have an x value of 0. This upper one has a y value of 5, comma in between the points. The next one, again, has an x value of 0. The y value is -5. So when you put those in, make sure you write them as points, ordered pair, xy pairs. And if your picture looks something like this and you've got two intercepts, they want you to put that comma in between. How is everybody with identifying their intercepts? We good? Not hearing anything, I'm going to clear that and go to the next question. Next question asks you to use the linear tool to graph it by finding and plotting its intercepts. This one is one where you do need to have pencil and paper work. And because they specifically ask you to graph its intercepts, the MyLabs part will not accept it if you use other points. And so if I'm graphing it using the intercepts, I'm going to make a table of values, x, y. My equation is -x plus 5y equals 10. And if I'm looking at the intercepts, for one x value, I'll put in 0. And then for my second point, I'll put in 0 for my y value. For the intercepts, you substitute in 0 for the other variable. So over here, when x is 0, this becomes 0 plus 5y is 10, which would just give me that 5y is 10. And so when I divide by 5, I get y is 2. So I intercept the y-axis at 2. And then for the x-intercept, I'm going to put in that 0 for y. So I get -x plus 5 times my y value is 0 equals 10. Gives me -x is equal to 10. I don't want -x, I want just x. So I'm going to divide by -1, and I'm going to get an x-intercept of -10. And so we'll use those 2 points and the line drawing tool to get our line. Again, if it asks for the intercepts, you must use the intercepts. And you're going to do 2 points on your table. For one, you'll put in 0 for x. The other, you'll put in 0 for y. How's that one? Any questions? If not, I'm going to clear it and go on to the next question. To graph equation x equals, well, we had said that y equals was a horizontal line. So if I have x equals, it's going to be a vertical line. And so for this line, I'm worried about where x equals -1. So I'll go to -1 on my x-axis. And then I'll go to any other point that has an x value of -1 to get that vertical line. Is everybody all right with that one? If so, next question. Okay, thank you for answering. Next question. You're asked to use the points shown on the graph to find the slope. I want to do this question 2 ways. One way, does anybody want to see my little kid way of doing it? Little kid way. Because obviously maturity is a function of height, so I will do absolutely everything in a little kid way. I'm going to start at my point that's furthest to the left, and I'm going to go up and over. And so little kid way, if I've got this graph in front of me, I'm going to count blocks. Do you see how we go up 3 over 2? And so I went up 3 over 2. Since it's up, it's positive. And so it's going to be a fraction, 3 over 2. And the slope is just a single number, a fraction. If you want to do it the grown-up way, our point to the left is the point -5, 1. Our point to the right is the point -3, 4. And I can use my slope formula, which is the difference in the y values over the difference in the x values. And so if this is my x1, y1, and this is my x2, y2, that's going to give me 4 minus 1 over -3 minus -5, which is going to give me 3 over 2. And so do you see it gives me the same answer as counting blocks. If the picture's in front of me, I am not above counting blocks because I'm lazy. I think that's probably the easier way to go, but you can also go through and do it using the formula. Is everybody all right with that one?
Yes.
Next question then. You're asked to find the slope of the line. And this time we've got the equation. Here the equation is x equals 2 y. From the equation to find the slope, we want to put the equation in our y equals mx plus b form, which means we want to solve for y. And so as I look at this equation, does everybody see y is not quite all alone? So I'm going to go through and divide both sides by 2. In doing that, I get 1/2 x equals y. Or if I were to write it in the other order, y equals 1/2 x. And if I compare that to my y equals mx plus b, does everybody see that m, the slope is 1/2? If the question asks for it, the intercept, because nothing's being added, b, the intercept is 0. But here my answer is just that the slope is 1/2. Everybody all right with that? Finding the slope by looking at the equation. And again, in order to do that, we've got to get y alone first, and the slope is the x coefficient. Remember, that's attached to the x. Enough on this one? Find the slope of a line parallel and perpendicular to the line through the pairs of points. This is kind of a multi-step problem. In order to find the slope of a parallel or perpendicular line, first we have to find the slope between those 2 points. And so if I call this one x1, y1, and this one x2, y2, you need to remember that the slope is the difference in the y's over the difference in the x's. And so working that out, I get 0 minus -3 over 0 minus -3, which gives me 3 over 3. Which would be 1. And now parallel lines have the same slope. And so this answer would also be that the slope is 1. Perpendicular lines, the slope is the negative reciprocal. So if I look at this slope as being 1 over 1, when I take the reciprocal, when I flip it, I still get 1 over 1, but I also want to change the sign. And so that gives me that the perpendicular line has a slope of -1. Oh, you guys, I just have to stop for a minute. My husband walked into the room, and over the weekend, I ordered shoes online, and they came. And he brought them in to show them to me. I'm sorry, it's such a distraction. If anybody's interested, I'll show you my new shoes at the end of class. But back to math. Does this make sense for everybody? In order to find the slope of a parallel line, we have to find the slope of the line. In order to find a perpendicular line, we flip it and change the sign. Are we good? Can you guys hear me all right?
Yes.
Yeah.
I just need a second to write a couple things down.
Oh, okay. Let me know if I'm going too fast, please. Any questions on this one?
No.
Great. Graphing is one of my favorite parts of this course. I enjoy graphing a lot. And so I get on a roll. Now this one, it asks us to read a graph. And I know there were homework problems that did this, and I know we looked at finding coordinates on a graph. But let's go through and look at this example. It shows Sean's hourly pay for each year. Use this graph to find the appropriate pay the year before 1991. If I remember correctly, this was in the function section. So 1991, as I look at my graph, is right here. The year before 1991 would be in this space. And so does everybody see here that that hourly pay would have been $6 per hour? Instead, if I ask for the year, let's see, before 1997. In 1997, his salary went up to 7.25, but the year before 1997, his salary was $7, and so on. Are we all right with reading information off of a graph? If so, I'm going to clear this one and go to the next question. Determine if these are solutions of the inequality. Oh my heavens, can anybody help me remember how to do that to see if I've got solutions? You folks all right? I'm just going to substitute. And so for the first point, I'll substitute in x equals 3 and y equals -1, giving me 2 times 3 minus 3 times -1, which is 6 plus 3, or 9. Is 9 less than or equal to 5?
No.
And so now we're going to substitute this time. The other point, x equals -3 and y equals +3. So when I take 2x minus 3y, it's less than or equal to 5. I should cross that one out. That's 2 times 3 minus 3 times 3. So that 6 minus 9, or -3, is less than or equal to 5. And that one's a yes, because negative numbers are always smaller than, oh, hello. Do you folks see what I did wrong? I made a careless mistake. Instead of substituting in 3 for x, -3 for x, I substituted in +3. And so that actually becomes not -3, but rather -15. And yes, it's still true. All right? Next question asks you to graph the linear inequality. I'm going to enlarge it. And I'd like you to remember that graphing a linear inequality is a little bit more than a one-step process. We've got to do a couple of things. First of all, I've got y is greater than or equal to 4x. As I look at that symbol, will this be a solid line or a dotted line?
Solid.
Solid, because it's got the line underneath it, solid. The line is y equals 4x. It's solved for y already, so my slope is 4 as a fraction, 4/1. There is no b, so my b is 0. So I'm going to go over here. I'm going to pick the line tool. I'm going to pick the solid line. I'm going to begin at 0. And my slope is up 4 over 1. And so now I've got my line. But I'm not done yet, because with these inequalities, we also have to shade. And now in order to shade, we have to pick any point as long as it's not on the line. My favorite point is 0, 0, but that's not going to work because it is on the line. So instead, is everybody all right if I use for my test point, the point 1, 1? So if I look at the point 1, 1, when I substitute y equals 1, is 1 greater than or equal to 4 times x equals 1? Is 1 bigger than 4? No. And since it's not, I don't want to include my point, so I'm going to dump my bucket of paint on the other side of the line. So with these, there are 3 things that I'm looking for. I'm looking for whether you have a solid or a dotted line. I'm looking for if your line is correct. And I'm looking for you to shade the right side of the line. Again, if all I get is that answer without any work, I'm not going to give credit. I need to see that supporting work. Okay? Is everybody all right with that one? What did that say? What? It says it's incorrect? Where did we go wrong? Y is greater than or equal to 4x. You guys, do you see what I did wrong? Solid line. The slope is up 4 over 1. So we're going through the origin, we're going up 4 over 1 with a solid line. And we want y to be greater than or equal to 4x. Let's pick 0.22 is 2 greater than or equal to 4 times 2. We used 1, 1 before, right?
Yes.
Yes.
Yes. So if I'm using 2, 2, is 2 greater than or equal to 8? No. And so we don't want to include that point. We want to shade on the other side, which would be shading here. And that was what I thought we did before, isn't it?
Yes.
Yep.
Okay. So, does anybody see anything wrong here? Intercept 0, solid line. When I checked my answer, that's the exact same thing I graphed before, wasn't it? Oh, well, I'm getting mad at it. We'll clear. Everybody comfortable with this one? All right, the next one. We're asked to graph the line x is greater than or equal to negative 11. Again, it's an inequality. This one is still solid. The line, when I go to graph it, would be the line, let's see, solid line, line tool, x equals negative 11. So we'll go to negative 11 on the x-axis. Does everybody remember x equals is a vertical line? Whoops. And so if I test the point 0, zero is greater than or equal to negative 11, so I'm going to shade that side. And we'll save it. And there we go. That one all right? If so, next question. Determine whether we have a solution to a system. Can anybody help me remember how to do this one? When we check, we're always going to substitute. So first one, we've got x equals 2 and y equals 5. So does 3 times 2 minus 5, substituting into the first equation, equal 1? Does 6 minus 5 equal 1? That checks. But we also have to check in the other equation, x plus 5y equals 11. So does 2 plus 5 times 5 equal 11? Does 27 equal 11? Thinking that's a no. So here our answer is no. And then the second point, we're checking x equals 1 and y equals 2. So in 3x minus y equals 1, does 3 times 1 minus 2 equal 1? Well, 3 minus 2 is 1, so that checks. And then in x plus 5y equals 11, does 1 plus 5 times 2 equal 11? Well, 1 plus 10 is 11, so that one checks, and this one's a yes. Is everybody comfortable seeing if you're having a solution to a system? Not hearing any complaints? We'll go on to the next question.
We can take this quiz again. Will it give us these same questions or different ones?
When you retake it, it will give you probably a couple of them will be slightly different. None of them will be identical. At least the numbers will change.
And we'll have the same amount of time to do the test?
I believe so. Let me double check in the settings to make sure I'm not lying in terms of the amount of time. Okay.
Thank you. So,
All right. So now to solve the system of linear equations by graphing, does everybody remember that that means that what we want to do is graph two lines? My first line is y equals negative 4x, and that's already solved for y. So when I compare that to y equals mx plus b, there's no b, so I begin at 0 on the y-axis, and m is negative 4 as a fraction, that's negative 4 over 1. So I'm going to make this a little bit bigger. I have to apologize, I'm struggling because I keep forgetting that I have to turn my finger back into a mouse before I do any of this. So I need my line tool. I'm going to begin at 0. And because my slope is negative 4, I'm going to go down 4 over 1. And there's my first line. Now my second line is the line 5x plus y equals 2. I want to get the y alone, so I'll subtract the 5x from both sides. Gives me y equals negative 5x plus 2. So here I'm going to begin at 2, and my slope is negative 5 over 1. So I'm going to turn back into a mouse. I'm going to pick my line tool. I begin at negative 2 on the y-axis. This time I go down 5, 1, 2, 3, 4, 5 over 1. And my solution is where my two lines cross. And looking at this picture, it looks to me like my two lines are crossing right here. And so that looks like my solution is the point negative 2, 8. And I would probably double check by plugging in. If x is negative 2, I would get y equals 8. So that one works. Over here, if x is negative 2, that's negative 10 You guys, you didn't yell at me. Did you guys see what I did wrong?
No.
B is
You-
2.
Oh, I was wondering, I
And
was
I
gonna ask
began
where
it-
you got -2.
That's what I did wrong. I wish you would have asked.
Yeah, I thought the same thing.
All right, you guys yell at me. I can pretend that I did that on purpose. Right? So, yeah, because that obviously was not checking. So let's erase this. And let's see. First, well, back to the mouse. First line, we began at 0 and we went down 4/1. Second line, let's do this right. We begin at 2, right? +2.
Yes.
And we go down 5, 1, 2, 3, 4, 5/1. And so now it looks to me like the solution is over here, which looks more like the point 2, -8. And so if x is 2 over here, y -8 would equal -4 times 2. And here, if x is 2, 5 times 2 plus y is -8, that does equal 2, so it checks. And so there you go. Did you folks see the value of that check there? I realized I made a careless mistake and was able to go back and find it because I did the check. So, let me save that. Whoops, back to the mouse again. Save that. So here I would check part A. And the solution is the point, I gotta move the chat. Is it gonna let me move the chat? Yeah. So what did we say our solution was? The point 2, -8? And of course it didn't type in there. Does everybody remember if the solution were infinitely many solutions, my 2 lines would have been the same line on top of each other. And if there was no solution, I would have had 2 parallel lines. And so, yay, we got it. Thank you, folks, for helping me find the error in my ways. Let's clear this. And I think we've got 2 more questions. What do we have? Is this a function or not? Let me make it bigger. Let me make it a lot bigger. Can anybody remember how to tell if it's a function or not? If I did my vertical line test, let's see over here, the vertical line crosses once. Over here, the vertical line crosses once. But over here, you guys see that vertical line crosses 2 points? If I were to look at those 2 points, this point would be the point -1, 4. And this point would be the point -1, -4. And since I've got a repeating x value, the answer to this question would be no, it's not a function. And we can check that. And yay, we've got it. Life is good.
Yep.
Then one last. Whoops. Find, oh, what's this? What's this all about? And again, this is traditionally a question that people forget in the middle of. I've got f of x equals -3x. Does everybody remember that's the same thing as saying y equals negative 3x? And so over here, when it asks me for f of negative 4, does everybody remember that means I'm going to let x equal negative 4? And so that would be negative 3 times, I'm plugging in for x, negative 4. And so my answer is 12. For f of 0, this time I'm substituting in for x 0, and I get 0. And for f of 3, this time I'm substituting in for x 3, which gives me negative 9. So, first f of negative 4 was 12. Then f of 0 was 0. Then f of 3 was negative 9. And we've got it. If the test is going to be similar to this, how are you folks going to do?
Pardon me?
If the test is going to be similar to this, how are you going to do? Is this all right? Are y'all going to get 100 for me?
I feel like I'll have to go back to my notes just to refresh my memory of the definitions, but
Yeah.
I feel like
What we did before you joined class, Lynn, was we went through and we did a real quick review of all of the rules so that you have to be able to plot a point, graph a line by a table. We have the slope formula, the point slope formula, the slope intercept formula, how to find the intercepts and all of that. So that would be my Reader's Digest condensed version. What you need to know for this chapter. How
Good
is
job.
everybody
Like
else?
that.
Is everybody else okay with the stuff in this chapter? Are you going to do all right on this test?
Hopefully. It's
Hopefully.
not too bad.
No. Honestly, I think graphing's kind of sort of ish fun because you get to draw pictures and the like. If you're comfortable with this, then we're going to do a little bit of introduction into that next section. And that next section deals with exponents, scientific notation, and polynomials. And I'm hoping that at least some of the phraseology here is familiar, so that the next chapter deals with exponents, scientific notation, and polynomials. And so I'd like to start today just by looking at exponents, what they are, and also looking at some of the exponent laws. And I'm going to tell you folks that I was always that type of student that somebody said, you do it like this, memorize it. It never stuck. I always needed to kind of see at least a little bit of an explanation as to why it worked, and that always helped me remember it. So I am going to take a couple of minutes with each of these laws to give you an idea as to why they work. But first, let's go through and let's define an exponent. And I'm going to, before I do a definition, look at an example. If I were to write 2 with the little 5 up above, can anybody tell me what that means? What does it mean if I have that exponent of
2 times 2, 5 times.
So we're going to go take 5, 1, 2, 3, 4, 5 factors of 2 and multiply them. And so 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. Before we go too much further, does everybody know how to evaluate an exponential expression using their calculator? If you have a calculator kind of like mine, for exponents, I'm going to go down a little bit over, go down, where is it? Here. A little bit, this caret up button. So on my calculator, to get 2 to the 5th, I'm going to type the number 2, then I'm going to use it, caret up, then I'm going to type the number, well, first I have to turn the calculator on and clear 2 caret up 5. And so, and my calculator, I don't know if you folks can see that display through all the reflections. I've got 2 caret up 5. And when I hit equal, it gives me that 32. And so this tells me that I'm going to multiply 5 factors of 2. And so in general, if I have b to the n, b is called the base, and this superscript here is called the exponent. And so if I have b to the n, it means I'm going to multiply b by itself n times. So b to the n is the product of n factors, each equaling b. And so let's go through and let's find 3 to the 4th. 3 to the 4th would mean that I have 4 factors of 3. And when you multiply that out, what do you get? Is anybody multiplying for me? Is anybody getting 81? Next one, I want to look at negative 3 to the 4th. And that would be 4 factors of negative 3. And so with your calculator, if you take negative 3 to the 4th, negative times negative would be positive times negative is negative times negative is positive. That should give me positive 81. Is there anybody, when you typed in negative 3 to the 4th, that gave you instead an answer of negative 81?
Nope.
This one would give me negative 81 the way it's written here, because you notice there's no parentheses. And so that means I'm taking the negative of 3 to the 4th. And so what's important to realize here is if you raise a negative number to a power, put it in parentheses, especially if you're using a calculator. So to raise a negative number to a power, we have to put it in parentheses first. As opposed to the second one, only the 3 is being raised to the power. And then we're going to take the opposite of that answer. So I guess what I'm trying to say is you must be careful when you're raising negative numbers to a power. Now let's say I have instead -5 to the third. That would be -5 times -5 times -5. And when I multiply that one out, it's -125. And instead, if I took the negative of 5 to the third, that would be the negative of 5 times 5 times 5. And so that one would also be -125. What if I have -7 to the second? Written like that, what are you going to get?
Just 49?
Positive 49. Great. And so if I backtrack and look at the examples, do you notice that if I take a negative number to an even power, the result is positive, as opposed to if I take a negative number to an odd power, the result is negative. So a negative base to an even power gives you a positive, as opposed to if I take a negative base to an odd power, that would give me a negative number. So far, so good. We could do this also. Can I turn the page, or do you guys need for me to wait a minute?
Oh, okay.
We could also do this using function notation. Let's say f of x is x squared. So f of any quantity will be whatever I put in the parentheses squared. So if I look for f of 3, that would be 3 squared, or 9. If I look at f of -6, that would be -6 quantity squared, which is 36. And so you sometimes see function notation for this. And again, especially if I substitute a negative number, I like to put parentheses around it when I do my substitution. You remember to put those parentheses around that negative number when you substitute. It's going to keep you from making sign errors. So, definition of exponents. Is this all stuff that you folks have seen before? I'm hoping so. So then the next place
Yes.
we're going to look at exponent laws. And they deal with, if I'm looking at operations, on expressions with exponents, having the same base. And the first exponent law that I'm going to look at is a product rule. And for this product rule, again, I'd like to take an example and do it out a slow, painful, arduous way to show you why the rule works as it does. And then we'll use the shortcut for the rest of them. So in my example, I want to take x to the third times x to the fifth. Painful way, x to the third, doesn't that mean I have 3 x's that are being multiplied? X to the fifth, doesn't that mean I have 5 more x's that are being multiplied? So 1, 2, 3, 4, 5, 1, 2, 3. When I multiply them all together, how many x's am I multiplying? 1, 2, 3, 4, 5, 6, 7, 8.
Oh.
And without drawing these out, can anybody see a way I could have gotten that result of 8 from the given expression? Couldn't
Just
I
add
have
the exponent value.
Yeah, but just add the exponents. So product rule says that if the bases are the same, to multiply, we're going to do 2 things. We're going to keep the base, and we're going to add the exponents. Or in general, we'll say if I have x to the m times x to the n, that product gives me x to the m plus n. And again, my bases have to be the same and they stay the same. And if I'm taking the product, if I'm multiplying, I add the exponents. So a bunch of examples. We'll simplify each. First, let's look at y to the 4th times y to the 6th. If I multiply 4 y's by 6 y's, how many y's am I multiplying altogether? 4 plus 6 would give me 10. What if I have z to the 2nd times z? Over here, if there's no exponent written, what's the exponent?
One.
And so that's saying z to the 2nd times z to the 1st. And so if I multiply 2 z's by 1 more z, wouldn't I have 3 z's altogether, z to the 1st? Next example, what if I have 2 to the 2nd times 2 to the 3rd? Does everybody see how my bases are the same? Up here, when my bases were both y, in my final answer, the base was y. When my bases were both z, in the final answer, my base was z. My bases are both x, in the final answer, my base was x. So here my bases are both 2. I am going to keep that base of 2. And instead I'll add the exponents, and then I'll evaluate 2 to the 5th is equal to 32. So even if the bases are numeric, the bases must be the same and stay the same. Next example is a little bit different because I have something like 3x to the third times 2x to the second. Now, some of them have the same bases, but other parts don't. When I have two expressions like this, I'm going to think of using the commutative and associative property to regroup. And so I'm going to regroup in such a way that I multiply the coefficients and multiply the variable parts. And in order to multiply the variable parts, we'll add the exponents on the variables. And so that would give me 3 times 2 is 6. X to the third times x to the second would be x to the fifth. So one more. If I have, let's say, negative 4x to the second times, let's say, 5x to the 7th. After I rearrange and take the product, what would my final result be? Negative 4 times 5 would give me negative 20. X to the second times x to the 7th would give me x to the, adding exponents. Final answer would be negative 20 x to the, oh Lord, I copied it wrong, x to the 9th. Is everybody all right with that one? Next one then. What if I have, last example, x to the 4th times y to the 5th? Do they have the same base?
Yes.
See, this one has a base of x. This one has a base of y. So this time, because they have different bases, I can't do anything. I'm going to stop here. The bases are different. I'm not going to multiply. I guess the only example otherwise would be if I had different numeric bases. And if I had different numeric bases, I would just go through and simplify. But how's that product rule? If I'm multiplying with the same base, I add the exponents. If the product rule says add the exponents, next place we're going is a quotient rule. And if I look at an example, something like x to the 5th over x to the 2nd, x to the 5th means in the numerator, I have 5 x's. X to the 2nd means in the denominator, I have 2 factors of x. When I divide out those common factors to reduce the fraction, I'm left with x to the 3rd in the numerator. X to the 3rd over 1 would be x to the 3rd. And again, to get that exponent of 3, If you want to, you can draw it out and cancel, but most people find that it's easier to subtract the exponents. So again, if the bases are the same, divide, we subtract the exponents. And when we do that subtraction, it's the exponent from the numerator minus the exponent of the denominator. And so if I have x to the m over x to the n, it would be x to the numerator exponent m minus denominator exponent n. And so here, if I look at examples, if I have y to the 12th over y to the 4th, we could draw it out, or we could remember when I divide common base, the base stays the same. It'll still be a y, but I'm going to subtract the exponents, 12 minus 4, to get as a final answer y to the n. Next one, if I have z to the 10th over z, what we need to remember is, again, if there's no exponent written, there's an invisible exponent of 1. And so now when I subtract the exponents, I'm left with final answer z to the 9. Instead, if I had something like 3 to the 8th over 3 to the 6th, then the bases are the same. So I have to keep the same base. And because we're dividing, we'll subtract those exponents. So that gives me 3 to the 2nd. And now we'll evaluate and get 9. Next example. What if I have 8x to the 7th over 2x to the 4th? Does it make sense that here I will divide the coefficients? So that 8 divided by 2 is 4. And then on the variable part, I'll subtract the exponents to divide. So that'll give me x to the 7 minus 4, or that'll give me final answer 4x to the 3rd. Instead, if I have 3y to the 5th over 6y, I'm going to think of that as 3 divided by 6 times y to the 5th divided by y to the 1st. Now over here, 3 over 6 gives me a fraction 1/2. And over here, subtracting exponents, I would get y to the 4th. And so my final answer would be 1/2 y to the 4th. One last example. What if I have x to the 5th, y to the 6th, over x to the 3rd, y to the 3rd? we don't have the same basis going across, so we can't multiply. We can think of having the same bases up and down. So we'll divide the x's. We'll have x to the 5 minus 3. And we'll divide the y's. Y to the 6 minus 3. And so my final answer would be x squared y to the 3rd. Is everybody comfortable? When my bases are the same, to multiply, I keep that base and add the exponents. If my bases are the same, to divide, I keep that base and subtract the exponents. Can I go on to the next page?
Yeah.
If that's all right, that gives us something that some of you might be familiar with, but it might be new to others of you. It gets me to the idea of what does it mean if I have 0 as an exponent. And so if I have 0 as an exponent, I'd like to start with an example. What if I have x to the 3rd over x to the 3rd? Is everybody all right? When I divide something by itself, that should always give me 1. But on the other hand, if I were to take x to the 3rd divided by x to the 3rd, and if I were to use this exponent law and subtract those exponents, wouldn't I get x to the 0? And so because these two are the same, these two have to be equal. And so we say that any base to the 0 power is equal to 1. Any base to the 0 power and 0 exponent is equal to 1. There is one exception though, except zero to the 0. We don't want to think of 0 multiplying to anything other than 0. And so we don't want this to equal 1. And so 0 to the 0 is undefined. It has no meaning. It's undefined. If you were to check it with your calculator, if you went 0, Carol, up 0, it will give you error with that idea that it's undefined. So if I have negative 2,387,941 to the 0 power, as long as my base is not 0, this is going to equal 1. If I have, with parentheses, negative 3 to the 0 power, that will equal 1. If my exponent is 0, it will equal 1. However, if I have negative 3 to the 0 power, here without parentheses, only the 3 has the exponent. And so here, because there are no parentheses, that's the negative of 3 to the 0, which is 1. Likewise, if I have something like 5x to the 0, because there's no parentheses, only the x has the exponent. And so only the x to the 0 is 1. So that's 5 times x to the 0 is 1. So with this one, my final answer would be 5. Instead, if I had written that in parentheses, 5x in parentheses to the 0, well, then I've got a single quantity to the 0 power, and that will equal 1. Does everybody see the subtle differences between these two examples?
How does -30 equal -1? Can you just tell me that?
Okay, over
I know
here,
it's pretty easy.
no, if I have -3 to the 0 power, that's because there's no parentheses. Order of operations, first thing I do is the exponents up. So I'm going to think of that as negative of 3 to the 0, which gives me the negative of 1, which is -1. Because over here, because the parentheses, the negative sign is also being to a 0 power, which means the final answer is +1. Over here, because there's no negative sign, we can also look at that -3 to the 0 as -1 times 3 to the 0, which would give me -1 times 1 or -1, if you want to look at it that way. Any better?
Yep.
Good. Thank you for asking. The other thing that the quotient rule gives us is, of all things, the idea of a negative exponent. And so again, to see how we can define this idea of a negative exponent, let's look at something like x to the second over x to the 6th. Using my subtraction rule, that would be x to the 2 minus 6, which gives me x to the -4. But what does that mean to have a negative exponent? Well, I want to revisit that x to the second over x to the 6th. And I'm going to see that as 2 factors of x in the numerator and 6 factors of x in the denominator. And I can divide out 2 x's from each. And so that's going to leave me x to the 4th in the denominator. And when I divide anything by itself, I'll be left with 1 in the numerator. So putting the pieces together, x to the -4th is going to mean 1 over x to the 4th. And a negative exponent is going to mean to take the reciprocal. X to the -n is equal to 1 over x to the n. And a negative exponent means that we're taking the reciprocal to the positive power. And so, for example, if I have 10 to the -2nd, I look at that negative exponent, and that negative exponent doesn't really have anything to do with the sign of my answer, but it has everything to do with the form of my answer. When I see a negative exponent, I think my answer is going to be a fraction. That part, that base with the negative power, I'm going to put in the denominator of the fraction. And when I make that move, my exponent becomes positive. And so this is going to be 1 over 10 to the 2nd, or 1 over 100. If I have y to the -12, I look at that, and usually the directions are going to tell you to write with only positive exponents. And so if I have to write it with positive exponents, when I see that negative exponent, I think I'm going to need to make a fraction. The factor with a negative exponent, when I move it to the denominator, that exponent will be positive. And then the coefficient will be in that numerator. So if I have, let's say, 3x to the negative fifth, that negative exponent tells me I'm going to make a fraction. That base with the negative exponent will go in the denominator. The exponent will become positive when I move it there. But over here, that 3, I can think of that as 3 to the first times x to the negative fifth. And that 3 has a positive exponent. And so any factor with a positive exponent will go in the numerator. But next example, if I have z to the 10th times z to the negative third, what I would do here is I would simplify before I start moving things around using its multiplication product rule. And so product rule says that when I multiply, I add those exponents. So that gives me z to the 10 plus negative 3, which is just z to the 7. And because that exponent is positive 7, I'm done. Instead, let's say I have y to the third over y to the negative second. Here I'd simplify using the quotient rule. That's y to the exponent of the numerator minus that of the denominator. And using my rules for signed numbers, minus a negative 2 is like plus 2. And so my final answer is y to the fifth. Instead, if I have x to the negative 2 over x to, let's say positive 2. First, I'll subtract exponent of the numerator minus exponent of the denominator. And again, I can do that because my bases are the same. Negative 2 minus 2 will give me negative 4. And now I've got a negative exponent left. If the directions ask me to express with only positive exponents, that negative exponent tells me I'm going to turn this into a fraction. The factor with a negative exponent goes in the denominator, and then that exponent will be positive. And then that coefficient would just be 1. How's this look so far? Let's do a couple more examples, and I know it's a little early, but I don't want to throw too much at you all in one day. So let's just do a few more negative exponent examples and then call it a day, if that's all right with everybody.
Thank you.
Next example, let's express with only positive exponents. And let's say I have x to the fourth, y to the negative fifth. I cannot combine those because the bases are different. When I go to rewrite it with a positive exponent, I know I need to make a fraction because I have a negative exponent. Everybody see here, the only thing that has a negative exponent on it is the y. So the y will go in the denominator and that exponent will become positive. The x has a positive exponent, so it will stay in the numerator. How's that one look? I'm going to switch the page, do a couple more. What if I have x to the negative 4, y, z to the negative 1? Other than writing them next to each other, I cannot multiply them because the bases are different. Because I want to express it with only positive exponents. Let's first look and see what has a positive exponent. Does everybody see y has an exponent of positive 1? Since it's positive, that'll go in the numerator. Which factors with a negative exponent will go in the denominator. And that exponent will become positive when I move that factor to the denominator. Next example, what if I have negative 3 x to the fourth, y to the negative third? If nothing else, because of that negative exponent, does everybody see I have to make a fraction? This expression has 3 factors. This first factor isn't the exponent 1. And so that number -3 goes in the numerator. The x has a positive exponent, so it will go in the numerator also. But the y has a negative exponent, and so the negative exponent tells me I'm going to move that to the denominator. And when I make that move, that exponent becomes positive. But then the question arises, what happens if I have a negative exponent in the denominator? We're going to work this out the long way once, and then we'll try to summarize it with a shortcut theorem. I've got 2 over that x to the negative second means I've got a fraction, 1 over x to the second. Does everybody remember a fraction means division? So that's 2 divided by 1 over x to the second. And then does everybody remember that in order to divide fractions, we keep the first one the same, we change the division to multiplication, and we flip the second. So my final answer is 2x squared. That's the long way. Short way is to say, well, if negative exponent means take a reciprocal, if I have a negative in the denominator, it will become positive when I move that factor to the numerator. So a negative exponent in the denominator becomes positive when we move that factor to the numerator. So let's say I have 3xy to the negative third over 2z to the negative fourth. If I were to be asked to rewrite with positive exponents, does everybody see that the 3x and the 2 all have positive exponents, so they'll stay put. The z, because it has a negative exponent in the denominator, that will become positive exponent when I move that factor to the numerator. And the y, if it has a negative exponent in the numerator, that exponent will become positive when I move it to the denominator. What do you think? Is that enough for one day?
Yep.
Yes.
Now, let me stop sharing. And I wish I were in a classroom and I could see your faces. Is this something that any of you have seen before? Or is this new for everybody?
It's pretty much new.
It's pretty much new. Okay. Let's, whoops, I am trying to adjust attendance. I'm trying to multitask, which is rude. Lynn, you came in late. And Jeremy, you came
Yes.
in late too? Oh, I got you already, Jeremy. I think I've got everybody. So we'll be spending a bit of time with exponents. It's going to lead us to scientific notation and polynomials. Between now and next week, that first exponent assignment, you can probably do the starting problems. Don't stress too much over it. Focus on getting that test done by tomorrow. And then over the weekend, if you have time, look at some of those exponents, okay? If you have any questions, shoot me an email. And I feel like a mom nagging. Please remember when you do that test in my labs, you have to do your supporting pencil and paper work, and you need to submit a picture of it in Blackboard. I'd appreciate it if you try to keep your pencil and paper work a little bit neat and organized, and at the very least, number it, so that when I'm looking at your question number 3, I can go and see for the work for question number 3 and so on. Does anybody have questions on